So when I last period, when I was thinking about one of the properties in particular, I was thinking about cohesion, and so what I was thinking is, I could give you a definition. You have probably a definition if you were like talking to people, but then I was thinking like, well, what am I looking for? And that's a different way of thinking about a concept or a term. Like when you talk about cohesion on your paper, what you might have written down is the tendency of water molecules to pull on each other, to be attracted to each other, the force between individual water molecules. Does that align with what anybody kind of said, more or less? Does that seem like what cohesion means to you? Like water molecules pulling on each other? Yeah. So here's my question. What would that look like? What would you actually see? Your name's Jackson, right?
Yeah.
What would you expect to see? How would you know that you were looking at something that was an example of cohesion?
I guess what I put for an example of cohesion is just like flowing water, where water is like continuing to hold more water.
Because it's pulling it along. So what you're saying is you would expect that if you had some water and somehow you got that water to move from point A to point B, if it was attached to some other water, it would kind of pull that along with it like a train, basically. So yeah, flowing water might be an example of that. Yeah. What else? Because the thing about flowing water is it might be sticking together, or it might just be that whatever made the first little bit of water go from point A to point B also made the second bit of water. Maybe they're stuck together, or maybe they're all being pulled down by gravity, for example. What's something else? What would you expect to see when things are sticking together? Like, forget about water. Like, how do you know if something else is sticking together? Like, let's say that you had a big pile of something. Like, let's say that I brought a bag of sugar in and just poured some out on the counter, and you asked yourself, will that sugar stick together? What would you do?
Touch them.
Huh?
You'll touch them or move.
You could touch them and move them, but how would you know if they were sticking together?
If they're touching each other.
If they're still touching each other? But things can touch each other without being sticking. Like these two pieces of paper are touching each other, but they're not sticking together. What's that? Try pulling it apart. Or you could, so that, I think that would be good, right? Like you see what it looks like imagine cookie dough. That's stuck together. So if you try to like separate two chunks of cookie dough that are not separate already, you can't do it by just pulling on one end. With sugar, it's easy, you just like move it. But if you took some sugar, how many of you, so this is a little bit of a tangent, but how many of you like to bake? Raise your hand if you, or just have ever baked. So brown sugar, brown sugar does kind of stick together, doesn't it? Like if you took some brown sugar and some regular white sugar, and you took the brown sugar and you kind of formed it into a ball, like with your hands, and then put it on the table and let go. Like some of it would probably break off and stuff, but a lot of it would sort of stick together. Whereas if you took the white sugar and you try to put it into a ball and you let go, and it would immediately all disappear. So I drew a picture of this, and I'm not the world's greatest artist. My apologies in advance, but this is what it kind of looked like to me. That you take a bunch of sugar with your hands, you form this ball, and then as soon as you move your hands away, it's just going to do this. So I don't see any evidence of cohesion here. So if I wanted to go out and look for an evidence of cohesion of water in the creek, what might I look for? Like if this is my example, what might I look for?
Spherical objects.
Little spherical, right? Some water that formed like a blob, a ball. Did anybody see anything like that in the creek? You did? Hang on. I know. Is it Lydia? Is that right? Yeah, what did you see? Water droplets, right? So here's what I'm talking about with like mind-blowing stuff. Because in fourth period, I thought to myself, I know, I'll go look for water droplets on something. That's a great illustration of cohesion. Well, I went down to the creek and this is what I saw. That's not what I saw. This is what I saw. This is just a leaf in the water. And look at this, like, blob. This is more than just a drop of water. And Miss Jackson and I were talking about this, because part of what's going on here is that this particular surface that this water is on is water repellent. It's got these little fuzzy things on it. It's pushing the water away. And so and what that does is it amplifies the cohesion of water, because the water isn't sticking to anything else. Look at that perfectly little, like, oblong, spheroid blob of water. If water molecules didn't stick to each other, it wouldn't look like this, would it? It would just spread out. And that's what I'm talking about. This was huge. Like, this was way bigger than I expected. It was like this big. Normally water droplets don't get this big, but normally water droplets don't form on something that's so hydrophobic. So that, to me, is one of those moments where I'm like, wow. Here's something else that I saw. How many of you examined either the muck by the creek, or by the cafeteria, or looked at the part of the creek where you could stand on in the quad by the little red rail and look down in the water? Did anybody get to that spot? Anybody see that? Here's what I saw there. I didn't take a picture of it, but it's pretty easy to draw even for someone of my limited artistic abilities. So here's what I saw. The retaining wall of the creek kind of looks like this, and the creek water is down here. This was all wet. You could see the retaining wall was all wet. And if you didn't see that, how many of you at least went and checked out the muck? Did you check out the muck? Okay, so the muck, it was the same kind of thing. I won't be able to draw it because I'm not very good, but basically, like, there was some grass here, and then there were these, like, spots where there was water, but then around the water, there was this mud, and the mud was higher than the water. The mud was, like, elevated up above the water. How is it that that's, like, water flows downhill, right? So what are we looking at both here and in the mud? What property of water are we looking at here? Okay, hang on just a second. I am thinking that, hold on. No. Alina, right? I'm thinking Alina knows. Which property of water am I looking at here? Adhesion. Water sticking to other things. Here's the crazy thing. This was several inches. That water was pulled up the retaining wall by adhesion. It was pulled up into the soil by adhesion. The water was actually going uphill on its own. Nothing else was pushing it up. There was no pump. There was nothing lifting it. It was sticking to here, and then it was like being pulled up because there was more of this to stick to up above it. Like, water goes uphill. We all know water flows downhill, but in this case, water is flowing uphill. So we've got cohesion with our blob of water. We've got adhesion with our, like, water literally being sucked up, concrete and dirt. What about surface tension? Did anybody see a really good example of surface tension? Bet you somebody did. David, did you see a good, or?
Oh yeah,
Yeah.
little water striders.
The water striders, right? So this isn't gonna work. There's a 0.1% chance we'll be able to pull this off. But when I was in college, I was actually really interested in the whole question of water striders. You never could find it. And I was taking a class, and one of the things that we were supposed to do was conduct an investigation. And so I decided that I wanted my investigation to be whether water striders were floating because of surface tension, or whether they were just like less dense in water. Has anybody ever wondered about that? Has anybody ever, like you've all seen water striders? I can't find it. I wrote a paper on this, but I can't find it right now. Has anybody ever wondered, like, are they floating? Because things can float, like a boat floats. It's not being supported by surface tension. How do you know if a water strider is being supported by surface tension? Yeah?
I might be wrong, but isn't it that they like hold air bubbles on their feet? Or they have, like,
You can, that's sort of what it looks like, doesn't it? Yeah, it's like little air. It's not really what's going on, but yeah, they have little hairs. And so, yeah, the effect of the surface tension is magnified. And there is some air in there as well. But they don't float. It's surface tension holding them up. And I figured it out because I measured. I figured out their density. I measured the legs of a water strider and the weight of a water strider and figured out how much was in contact with the water. And I basically figured out, are water striders more or less dense than water? And the answer was they're more dense. And then I tested it by putting a little bit of soap in the water, and bloop, right, it just went down to the bottom of the petri. They didn't drown or anything, it just went down to the bottom of the petri dish. And that kind of thinking is what I want you all to have. Some of you have it already, which is fantastic. If you don't, that's where we're going together, because my goal is to help you do well on the AP exam, and the AP exam is built to have them thinking about things in just the same way that we were all thinking about, right? So that's going to be our plan. This work, hang on to it. I'm going to have you turn it in on Friday. We're going to do our first actual investigation on Friday as well. In the meantime, enjoy your afternoon. Congratulations, you made it through the first day of 25-26.